Lucid is an embedded systems development tool from nCapsa that is particularly suited to the development of applications for digital TV platforms. In this demonstration, we will show how the elements of Lucid cooperate to develop part of a PVR application, namely, as shown here, a menu allowing the selection of a program from a pre-recorded list of TV programs. Lucid consists of three key elements: Lucid Application Builder, which supports a graphical approach for creating embedded applications. This approach is entirely code-free, allowing application experts rather than embedded programmers to rapidly define the functionality of an application in terms of functions supported by the target platform. Lucid GUI Builder allows user interface layouts to be created. The very small data files generated by Lucid Application Builder and Lucid GUI Builder are downloaded onto the target platform, which runs EHS, or Event Handling System. EHS is the target-specific component of Lucid, which receives the application description files from Lucid Application Builder and Lucid GUI Builder. We will now see how an application is developed using these elements. Within Lucid Application Builder, applications are constructed graphically by linking event flows and data flows from predefined function blocks. Function blocks are selected from a collection of available blocks, which can be generic, such as this. Alternatively, they could be target-specific, such as this block that can initiate playback on a specific target platform. Complex functionality can be partitioned into a hierarchy of subsystems. This can be done top-down or bottom-up. In this case, we work top-down and define a subsystem that will be later populated with functions. We add ports to the subsystem to allow functions at the current level to be connected with functions within the subsystem. Ports can be event ports, which are used to arrange the sequence of functions that are performed, in this case an output event port, or data ports, which allow data to flow from one function to another. Ports of the same type can be connected together. In this case, the event signaling that up or down arrows on the control have been pressed are connected. Navigating within the application is performed via the Project Explorer or directly by double-clicking subsystem blocks. Lucid can use its bottom-up encapsulation to reduce application complexity. Here, we group together some related functionality into a subsystem block. Diagram complexity can also be reduced by tagging lines. Function blocks representing on-screen items such as text, graphics, or other more complex entities can be added to the application. In this case, we see text and bitmap objects. The functionality within the application determines the circumstances in which the objects are displayed. We now see how these objects are configured visually. To create a graphical user interface to accompany this application, Lucid GUI Builder reads the application configuration and extracts GUI widgets. These allow specific bitmaps to be selected. They also allow text properties such as background color, text color, and location of the text boxes to be defined. Once it's been completely configured, the GUI can be transferred to the target. From this point on, it's actually possible to run the application on the target, and this is what we see now. That is the end of the presentation. I'd like to thank you very much for your attention.